Hello everyone, I hope everyone is doing well. I'm sure you are preparing for your Cambridge examination. So today I'm going to discuss the Physics IGCSE Paper 2, which is the extended multiple choice from February-March 2025, and I'm taking the component 2. Okay, let's start. Question number 1. The diagram shows three forces acting on an object. What is the magnitude of the resultant force acting on the object? So we can see here the 1 Newton and 9 Newton forces. They are in opposite direction. So we can just subtract them. Therefore, the resultant force is 8 Newton to the right. And then we still have the 6 Newton upward. Okay. Therefore, we can find the resultant force using Pythagoras. Okay. So resultant force is the root of 8 square plus 6 square. So the root of 100 is equals to 10 Newton. So the answer is B. Okay, question number 2. Which row defines speed and velocity? So speed is distance traveled per unit time. We have B or D. And then velocity is displacement per unit time, or speed in a specified direction, or speed in given direction. So we have B or C. So the answer is B. Okay, number 3. The graph shows the journey of a motorcyclist. Which section of the graph shows the time when the motorcyclist is stationary at some traffic lights? So stationary means that the speed is 0 or at rest. Since this is a speed time graph, so the part of the graph in which the speed is 0 is C. Okay, question number 4. The acceleration of free fall on the moon has 1/6 of its value on the Earth. On the Earth, an astronaut's mass is measured as 60 kilogram. Okay. Which row gives the mass and weight of the astronaut on the Earth and on the moon? Okay, so on Earth, the mass is 60 kilogram. So the weight is mass times gravity. So 60 times 9.81, we have 590 Newton. While on the moon, of course, mass will not change wherever you are. Okay, so the mass will be 60 kilogram. Weight is equals to mass times gravity. So the mass is 60. And the gravity is 1/6 of the gravity of the Earth. So we have 98 Newton. So it's D. Okay, number 5. The load extension graph for a material is shown. Which point indicates the limit of proportionality? Okay, so the limit of proportionality is the point to which the load and extension is still proportional. So it means after limit of proportionality, the load and extension will no longer proportional. So we can see up to point A, it's a straight line, so it means it is directly proportional. But from point A onwards, we can see that it's starting to curve. Therefore, A must be the limit of proportionality. Number 6. An object of mass 4 kilogram is moving with a velocity of 3 meters per second in a straight line. What is the momentum of the object? Okay, so momentum is mass times velocity. So 4 times 3 equals to 12 kilogram meter per second. Okay, number 7. A tall cylinder is partly filled with two liquids which do not mix. The two liquids have different densities. A student measures the pressure due to the liquids at different depths. Which graph shows how the liquid pressure varies between positions P and Q? Okay, so P is at the top of the liquids and then Q is at the bottom. Okay, I'm going to call this as liquid 1 and liquid 2. Since liquid 2 is at the bottom, so we can tell that liquid 2 has greater density than liquid 1. Now we know that pressure is equals to rho GH, which means that pressure is proportional to the density and pressure is also proportional to the depth. Okay, since P is at the top of the liquids, which means that there is no depth or the H is 0, then for sure the measurement of pressure will start from 0. So we have this, this and this. So D is not possible. And then as we measure it downward, okay, the depth is increasing, therefore the pressure will increase. ABC, all pressure increases, but we understand that liquid 2 has greater density, which means that the increase in pressure will be greater compared to the increase in pressure in liquid 1. So the gradient must be more in liquid 2, which eliminates option C because it's a straight line, so there is no difference in the gradient, so it can't be the answer. We have A and B, and from the drawing we can tell that in B the second part has greater gradient. Okay, so B is the answer. Okay, number 8. A tennis ball with momentum 2.3 kilogram meter per second is struck by a tennis racket. The racket causes the direction of motion of the ball to reverse. Okay, if it is reversed, which means that the momentum will be negative compared to the initial momentum. Okay, the racket exerts an average force of 1500 Newton during the impact with the ball. The racket and ball are in contact with each other for a time of 0.0024 seconds. What is the magnitude of the momentum of the ball as it leaves the tennis racket? So force is the rate of impulse or the rate of change in momentum. As we can see from the question, when the ball is struck, its motion reversed. Therefore, the change in momentum will be P1 minus negative P2. Therefore, it will be equals to P1 plus P2. Okay, so putting the values into this formula, 1500 equals to P1 is 2.3 plus P2 divided by the time is 0.0024. 1500 times 0.0024 is 3.6 equals to 2.3 plus P2. Therefore, P2 is equals to 3.6 minus 2.3, we have 1.3. So the answer is A. A car is traveling at a speed of 8 meters per second. The kinetic energy stored in the car is 32,000 joules. Okay. What is the kinetic energy stored in the car when its speed increases to 16 meters per second? Kinetic energy is equals to half mv square, which means that the kinetic energy is proportional to the square speed. Now we can see that the initial speed is 8 and it increases to 16, which is 2 times. Okay, therefore we can say that the kinetic energy will be increased 2 square or 4 times of the original kinetic energy. Therefore, the new kinetic energy will be 32,000 times 4 equals to 128,000 or 130,000 to two significant figures. So the answer is D. If you are not so comfortable using proportionality, you can just find the mass first. I'll show you how to do it with a different method. So kinetic energy is half mv square. So first you put in the initial value. So 32,000 equals to half times m times 8 square. So 32,000 times 2, we have 64,000 equals to 8 square is 64, 64 m. Therefore, the mass is 1000 kilogram. After you find the mass, you can use the mass to find the final kinetic energy. So now, using the same formula, half times 1000, but now the speed is 16 square. Okay, so half times 1000 times 16 square is equals to 128,000, which is the same as our answer before. Yeah, so to two significant figure, it's 130,000 joules. Same answer, D. You can choose whichever convenient to you. Okay, next we continue to number 10. The sun is not the primary source of energy for which resource? Most of our energy, the primary source is the sun, except for the geothermal and the tidal. Yeah, we have the tidal here. So tidal happens due to the gravity of the moon. So it is not primarily from the sun. Okay, continue to question 11. An experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoons. An ice cube is placed on one end of each spoon and the other end is heated gently. Which row has the correct prediction and correct explanation? Okay, let's see the options one by one. A. The ice cube would melt more quickly on the metal spoon. This is a correct prediction. And we predict that because metal is a good conductor. Yes. Okay, so apparently the answer is A, but let us check the other options also. Okay, B, the ice cube would melt more quickly on the metal spoon. Yes, because plastic is a good conductor. No. And then C and D on the plastic spoon. No. Okay, let's continue to question number 12. 4 students determine the efficiency of 4 different electrical devices. The teacher knows that one student has made a mistake in the calculation. Which value for the efficiency is not correct? So efficiency is basically showing how many percentage of the input energy has turned into a useful energy. Therefore, it cannot be more than 100%. So if you see the options, in D we have 102%, which cannot be possible for the value of efficiency. Number 13, a sample of gas is sealed inside a container of fixed volume. The temperature of the gas is increased. Which statement explains why the pressure of the gas increases? A. The gas particles collide with the walls of the container more frequently. Yes, since the temperature is increased, the gas particles will move faster and therefore they will collide more frequently with the walls of the container. Then the average force will be increased, therefore the pressure of the gas increases. So the answer is A. Okay, 14. A student does an experiment to determine the specific heat capacity of a metal block. She records the following measurements. Energy supplied is 12 kilojoules. Okay, let's just convert it directly to SI units, so 12,000 joules. Initial temperature is 20 degrees Celsius and final temperature is 45 degrees Celsius. Therefore, the change in temperature or delta theta is 45 minus 20, so 25 degrees Celsius. Then the mass of the metal block is 600 gram. So I'm going to convert it to kilogram. So we have 0.6 kilogram. Now the question, what is the specific heat capacity of the metal block? So energy, E, or in this case the heat energy, so Q equals to mc delta theta. So the C is equals to the energy divided by mass times delta theta. So 12,000 divided by 0.6 times 25 equals to 800 joules per kilogram degree Celsius, so D. 15. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into warm surroundings. Which statement about the metal block is correct in the morning? So in the morning, the metal block is moved from cool to warm surrounding. So what will happen to the metal block? A, the internal energy of the metal block increases. Yes, correct, because it is being moved to a warmer surrounding. Let's check the other options. Temperature decreases, not possible, it's warmer. Convection transfers energy throughout the metal block. No, convection doesn't happen in solid. The metal contracts slightly. Contraction happens when the temperature is colder. This one is warmer. Okay, so the answer is A. Now number 16. A fixed mass of gas is contained within a sealed syringe at a pressure of 100 kilopascal. The plunger is slowly moved until the pressure is 80 kilopascal. So we have initial pressure and final pressure. The final volume of the gas is 50 cubic centimeter. This is the final volume. The temperature of the gas does not change. What is the volume of the gas before the plunger is moved? Okay, P1 V1 equals to P2 V2. So P1 is 100 times V1 equals to P2, which is 80, times V2, which is 50. So V1 is 80 times 50 by 100. So 40. B. Okay, should I convert this kilopascal into pascal and the cubic centimeter into cubic meter? For this formula, because you are just simply comparing the initial and the final condition, as you can see here, this is the multiplication of P1 V1 and P2 V2, so you don't really need to convert them. Let's move on to question number 17. The diagram shows the more energetic water molecules escaping from the surface of liquid water. What is this process called? This process is called evaporation. Number 18. A hot object emits thermal radiation. Which row describes two changes that both reduce the rate of emission of radiation? Surface area. The greater the surface area, the greater the rate of emission. And since we are trying to reduce the rate of emission, then it must be a reduced surface area. How about surface temperature? The higher the temperature, the more the rate of emission. So if we want to have a reduced rate of emission, then we should reduce the temperature. Okay, so the answer is D. Number 19. The frequency of a wave is double. Okay, so F2 is twice of the initial one. Okay, the speed of the wave does not change. So V2 is still the same as V1. What happens to the wavelength of the wave? V equals to F lambda. Therefore, lambda is equals to V over F. Since the speed stays the same, but then the frequency increases or double, therefore the wavelength will be half. It halves. Okay. If you're confused with the proportionality, perhaps I can show you a more detailed method. Okay. So wavelength is equals to V over F. Therefore, the first wavelength will be V1 by F1. The second one will be V2 by F2, in which V2 is equals to V1 and F2 is 2F1. Therefore, this will be half F1 by half V1 by F1, so half of lambda 1. Okay, you can see here V1 by F1 is lambda 1, so I substitute the V1 by F1 as lambda 1. So we can see that the second wavelength is half of the first wavelength. We continue to question number 20. Which statement about ultrasound is correct? It has a higher frequency than audible sound and it is a longitudinal wave. Yes, this is correct. Oh, this paper is nice. Every time they give us options, every time they ask about the correct statements, most of the answer is A. Okay, let's continue with question number 21. Which statement about the image produced by a plane mirror is not correct? The image is real. No, it's a virtual image. Oh, again it's A. Okay. Number 22. A ray of light is incident on a boundary between air and water. Under which conditions is the ray of light totally internally reflected? Okay, so if we have two medium, let's say this is air and then this is water. So total internal reflection can only happen when the light travels from the denser medium to the less dense medium. Okay, and when the angle of incidence is greater than the critical angle, then it will be totally internally reflected. So let's take a look at the options. The ray initially in the air, no, this is already wrong. The ray initially in the air, no, wrong. The ray initially in the water, yes, is incident on the water-air boundary at any angle of incidence, no. The ray initially in the water, yes, and then at an angle of incidence greater than the critical angle, yes. Okay, this time it's not A, it's D. Okay, number 23. A converging lens is used to make an image on a screen. Which type of image is formed on the screen? If the image is formed on the screen, so it must be real image. One of the difference between real and virtual image is that real image can be projected onto screen, but virtual image cannot. Okay? And then next, will it be inverted or upright? Real image formed by a converging lens is always inverted. It will be upright if it is virtual and in the same side as the object. Okay, 24. A negatively charged rod is brought near to a metal sphere. A positive charge develops on the surface of the metal sphere closest to the negatively charged rod. Why is this? Electrons in the sphere are attracted by the negatively charged rod. No, electrons are negative, so it cannot be attracted by negatively charged rod. Electrons in the sphere are repelled by the negatively charged rod. Yes, same charges repel, so electrons are negative, so they will be repelled by the negatively charged rod. Continue to 25. The EMF of a cell is defined in terms of which quantities? A. The energy transferred by the cell in moving charge around the circuit. Yes, oh, this is so nice. Every time they ask for something with definition or again it's A. Okay, number 26. A resistor of resistance R is connected to a battery of EMF V. There is a current I in the resistor. Power P is dissipated by the resistor. In time t, the energy transferred is E. Which expression is correct? Power is the rate of energy. Therefore, energy is equals to power times time. And then electrical power is the product of the EMF or the voltage and the current flowing. Energy is power times time, but power is V times I or I times V. So energy is I VT. Okay, so A. 27. A copper wire of length 80 centimeter and cross-sectional area of 0.2 millimeter square has resistance R, which length of copper wire of cross-sectional area 0.4 has resistance R. R is equals to resistivity length by area. But since both of them are copper wire, so we can kind of ignore the resistivity. So we can just say that the resistance is proportional to the length divided by the area. For the first wire, the resistance is equals to the length is 80 and then the cross-sectional area is 0.2, so this is 400. Therefore, for the second wire, the resistance, which is 400, is equals to the length divided by the area is 0.4. So it will be 400 times 0.4 equals to 160 centimeter. Next, number 28. 4 identical resistors are connected to a battery as shown. Each resistor has a value of 120 ohm. Okay, so each of them is 120. Okay. Resistor R4 is removed. Okay, this one is removed. Which effect does removing this resistor have on the effective resistance of the circuit? In the initial circuit, the 3 of them are in parallel. Therefore, the effective resistance will be 120 divided by 3. So 40 ohm. And then the 40 ohm will be in series with 120. So the total resistance will be 120 plus 40 equals to 160 ohm. This is the initial circuit. And then after removing R4, then only 2 of them will be in parallel. Therefore, the effective resistance will be 120 divided by 2. So 60. And then 60 will be in series with R1, 120. So the effective resistance will be 120 plus 60 equals to 180 ohm. Therefore, the resistance increases to 180, or it increases by 20. So it's C. Continue to number 29. The resistors in the circuit shown are identical. Okay, so these resistors are identical. The reading on voltmeter V2 is 1.5 volt. Where is V2? Oh, this one, 1.5 volt. The reading on ammeter A2 is 0.5. Okay, this one is 0.5. The reading on ammeter A3 is 0.25. This one is 0.25. Okay, the question: what are the readings on ammeter A1 and voltmeter V1? Okay, as you can see, there is a junction here, and according to the first Kirchhoff's law, the sum of current entering a junction is equal to the sum of current leaving the junction. So A1 equals to A2 plus A3. So equals to 0.5 plus 0.25 equals to 0.75 ampere. Okay, now what about the voltmeter? Okay, since this is 1.5 volt and the resistors are identical, it means that in this branch, then this one is also 1.5 volt. So the total voltage will be 3 volt in this particular branch. In parallel, the voltage is always equal for every branch. So it means if this is 3 volt, then then it will also be threefold in this branch, and it will also be threefold in the EMF. Okay, so it's D. Continue number 30. A wire is moved in the region between the poles of a magnet. A current is induced in the wire in the direction shown. Okay, in which direction is the wire moved? Okay, the common confusion in this kind of question is usually, do I use the left hand or do I use the right hand? Okay, so the first thing to check is there any current or movement of charge in the question? The question says a current is induced. So it means initially we didn't have current. So we are inducing or generating the current. Since the current was not there initially, so we are going to use the right hand. Okay, once more, if current is there, we use the left hand. But if there is no current and we are inducing or generating the current, okay, no current initially, so we are going to use the right hand. Okay, now we have magnetic field to the right. Okay, magnetic field to the right, and then the induced current is downward. So using the right hand Fleming, where F or the force is the thumb, B is the magnetic field shown by the index finger, and then I, the current, is shown by the third finger. Okay, so B to the right and then current down. Therefore, the thumb is pointing perpendicularly into the plane of the beam. Okay, 31. A fixed resistor is connected to the secondary coil of a step-down transformer. The transformer is 100% efficient. The variable resistor is adjusted so that the current in the fixed resistor decreases by 0.25 ampere. What is the change to the current in the primary circuit? So the transformer is 100% efficient. It means that the power in the primary will be equal to the power in the secondary. Power is voltage times current. So the voltage times the current in the primary must be equal to the voltage times the current in the secondary. This is a step-down transformer, which means that the voltage in the primary is greater than the voltage in the secondary. Okay, so from this equation, we can tell that when the current in the secondary decreases, then the current in the primary is also decreases. But since the voltage is greater in the primary, so even though the current decreases, it will be decreased less than the decrease in the secondary. Okay, so it decreases by less than 0.25. 32. An electrical device changes the voltage of an electrical supply from 240 AC to 20 volt AC. What is this device? As you can see, the voltage is decreased from 240 to 20. So it is a step-down transformer. Okay, so it's a transformer. 33. An AC generator is set up so that its coil of wire is perpendicular to the magnetic field. The coil of wire is rotated slowly to produce an alternating electromotive force or EMF. A graph of the induced EMF against time is plotted as the coil rotates. Which section of the graph represents a rotation of 3/4 of a turn? Okay, one cycle is like the full wave, like this. Okay, so if the question is talking about 3/4, then it must be from here until here. So ORC. 34. A uranium nucleus U-23892 decays to form thorium by emitting an alpha particle. Alpha particle is 2 protons and 2 neutrons. Thorium decays to protactinium by emitting a beta particle. Beta particle is electron, so -1. Which row gives the atomic number and mass number of this isotope of protactinium? So initially 92238 emits alpha particle, becomes thorium and emits alpha particle. So this will be 90 and this is 234. Thorium decays to protactinium, okay, and emits beta particle. So this will be 234 and then this is 91. 91 and 234, C. 35. Which row shows what happens when a nucleus decays by emitting a beta particle? A neutron changes to a proton and an electron. Yes, correct. And the particle emitted is electron. Yes, correct. A again. 36. Which precaution does not always reduce a scientist's exposure when working with sources of ionizing radiation? A. Ensuring the scientist only works with sources of radiation that have long half-lives. No, this won't reduce the exposure. So the answer is A. Oh, again A. 37. A detector is placed near a radioactive isotope and records a count rate of 700 counts per minute. The half-life of the isotope is 8 minutes. The average background count rate is 60 counts per minute. What is the count rate measured by the detector after 16 minutes? Okay, so the initial count is 700, but with a background count rate which is 60, so the initial activity is basically only 700 minus 60, so 640. After 16 minutes, it means after 2 half-lives, because the half-life is 8 minutes, so 16 minutes will be 2 half-lives, which means that the 640 would have been reduced to 320 and then 160. This will be the count rate after 16 minutes, but because there is a background radiation of 60, so the detector will measure the count rate along with the background. So 160 plus the background radiation 60, so it will be 220 counts per minute. So D. Continue 38. The nucleus of an isotope of nitrogen N absorbs a neutron. It then decays into an isotope of carbon C and emits X. What is X? Okay, 076, so this must be 1, and then 15, so this is 1. 1 is proton. 39. The graph shows how the strength of the Earth's gravitational field varies as distance from the Earth's surface increases. Okay, as the distance increases, then the strength decreases. Okay, which row describes the effect that this has on the mass and on the weight of an object as it moves further away from the Earth's surface? Mass, of course, it will be unchanged, but then as it moves further away from the Earth's surface, the gravitational field strength will be decreased. Therefore, the weight of the object will decrease. Number 40. A student plots a graph of the speed of different galaxies moving away from the Earth against their distance from the Earth. Using the best straight line shown on the graph, what is the value of the Hubble constant h0? Okay, so the value of the Hubble constant is basically the gradient of the graph. So we can use probably this point and this to find the gradient. So we use this 20 million divided by 1 times 10 to the power of 25 is equals to 2 times 10 to the power of negative 18a. So that will be all for this paper. I hope it is clear enough for you. If you have any questions, feel free to ask in the comment section. I will get back to you as soon as possible. And if you find this video helpful, you can like it and share it with your friends. And don't forget to subscribe if you haven't subscribed. And I'll see you on my next video. Goodbye.